A farmer has 60 meters of fencing to enclose a rectangular garden against a straight wall open bracket, so only 3 sides need fencing close bracket. Find the dimensions that maximize the area by forming and solving a quadratic. We define our variables and set up the constraint equation based on the available fencing. The width of the garden is x, and the length is y. Since the garden is against a wall, only 3 sides need fencing, which gives us the equation x plus 2y equals 60. We solve the constraint equation for y to express the length in terms of the width. Then, we substitute this expression into the formula for the area of the garden, which is A equals xy. This gives us the area as a function of x alone. To find the maximum area, we take the derivative of the area function with respect to x and set it equal to 0. This gives us the critical point open bracket s close bracket where the maximum might occur. Solving the equation 30 minus x equals 0 gives us x equals 30. We substitute the value of x back into the equation for y to find the corresponding length. This gives us the dimensions of the garden that maximize its area.